So if you take a sighted person and you put them in the scanner and you blindfold them tightly, what you see is that the visual cortex at the back of the head starts responding to signals of hearing and touch within about an hour, which is much faster than anyone would have guessed. Now, obviously, it's not growing new connections, new axons from the neurons into that area. Instead, one thing that we know is that the brain is heavily cross-wired. So you have neurons from the auditory cortex and from areas involved in touch and so on. And these are reaching all around. But what happens is when there's no more visual information coming in, suddenly the brain says, oh, I guess there's no more visual information coming in. That's fine. I guess we'll start taking over that territory that is otherwise going to be lying fallow. Anyway, it turns out that this can happen really rapidly. And what my student and I realized as soon as we read that paper was, gosh, the problem is that the planet rotates into darkness 12 hours out of every 24. That means that the visual cortex would be in danger every night of getting taken over by hearing and touch and other things. And so what we realized is this is actually the basis for dreaming. The reason we dream at night is because these very sophisticated mechanisms in the brain that are hardwired in there every 90 minutes or so become active and slam activity back into the visual cortex. And if you look up the circuitry for dreaming, you'll see that it only goes into the visual cortex and that's it. Because it's the visual cortex, we of course interpret it as visual. And presumably the content of dreams has to do with whatever synapses are hot from whatever you've experienced in the daytime. So the point is, you get this activity that's slamming back into the visual cortex every 90 minutes, and we interpret it as seeing stuff. And because the brain is a great storyteller, we impose narrative on top of that. And we wake up and we say, oh my gosh, I just had this weird experience. But the point is, it is the visual system's way of defending itself against takeover from the neighboring area.